Alright, today's lesson is about applying deductive reasoning. We've already done inductive reasoning. What do you remember about inductive reasoning? It used, I'm looking for one word, starts with a P. Looks like some people need to study, so let's write it down. Inductive reasoning uses patterns. A lot of you need to study. It's obvious you're not looking back at your notes if you're not remembering that simple topic. Deductive reasoning is different. That was our only definition for today. What is deductive reasoning? Deductive reasoning uses not patterns, but facts, definitions, and properties. Facts, definitions, and properties. I kind of remember deductive and definitions. And if I can remember definitions, I can typically remember facts and properties. That's how I remember this. And I know if this one is definitions, then inductive is patterns. That's your job to memorize that. That is a question on the test. Today we're using two laws of logic. Remember, logic, once again, is something we're trying to develop in your brains. So, two types of laws of logic. These are tricky for some people who do not study. How do you study this? You learn their definitions, you learn their processes. So, once again, law of detachment, law of syllogism is how you pronounce it, syllogism. These are the two laws of logic. So, the first one, it says, if the hypothesis of a true conditional statement is true, then the, what follows hypothesis, conclusion is also true. If the hypothesis of a true conditional statement is true, then the conclusion will also be true. And we'll see this in an example here shortly. I like the next one, though, a lot, because I think it is simple. But some people make it difficult. The law of syllogism says, if hypothesis P, then conclusion Q. Just making up little variables. Then it gives another conditional statement. If hypothesis Q, then conclusion R. Then it gives a third one. If hypothesis P, then conclusion R. Here's what it wants you to do. It wants you to use the first two to create the third. I would write that little note out to the side. It will give you two conditional statements. Your job will be to use them to make the third, or check to see did they do the third one correctly. And here's how it works. Look at these first two. Do they have something in common? What do they have in common? They both have Q's. Conclusion Q. Oh, and hypothesis Q. They both have Q's. What we do on law of syllogism is we cut the repeated parts. And we write what's left. So if we cut the repeated parts, talking about Q, what is left? If hypothesis P, then conclusion R. And that's exactly what they write as their third conditional statements. We'll see this in action here shortly. On example 1, it says, use the law of detachment to make a valid conclusion. So the key thing is you have to read these. And remember, we're looking for true statements. We're trying to make sure they give an if-then statement and then a little situation. So make that note out to the side. For law of detachment, they will give a conditional statement. They will give an if-then statement, followed by a little situation. You have to determine, will this occur in this given situation? That's what we're going to examine right now. Give you a second to write that down. So in the first one it says, if two angles have the same measure, then they are congruent. That's what you have to have in your mind as a conditional statement. If two angles have the same measure, they're congruent. We know that fact. So here's the little situation. A is equal to B. What can we conclude then? If they have the same measure, what are we supposed to conclude? A and B are congruent. So that would be our conclusion. So we could say angle A is congruent to angle B. Basically, we just kind of rewrote this conclusion to apply to this situation. Once again, this little symbol is the congruent symbol. It has an equals with a tilde or tilde over it. Part B. Once again, they gave a conditional statement. This one doesn't have if-then, but that's okay. So they give a conditional statement and then a little situation. So let's read it. Jesse goes to the gym every weekday. Jesse goes to the gym every weekday. Get that idea in your mind. That's a conditional statement. If today's a Monday, what's going on? Jesse's going to the gym. So we can conclude that Jesse is going to the gym, or will go to the gym. On example 2, if possible, use the law of syllogism to write the conditional statement that follows the pair of true statements. So once again, thinking back to your definition, we should remember that they'll give two if-then statements and then a third one that follows from it. We got to see what will happen. So here are the two if-then statements, and once again, we're looking for repeated pieces to cut. Are there any repeated pieces in that first set of conditional statements? So it says if Ron eats lunch today, then he will eat a sandwich. If Ron eats a sandwich, then he'll drink a glass of milk. Yeah, it does have a repeated part. It's eating a sandwich. So if we cut the eating the sandwich, we can write what's left, and that's our solution. So once again, our solution is what is left. So down here you should say, if Ron eats lunch today, then he will drink a glass of milk. I'm going to pause, let you try part B. See if you can do that one. On part B, it says, if x squared is greater than 36, then x squared is greater than 30. Then, if x is greater than 6, then x squared is greater than 36. Is there repeated information? Yeah, x squared is greater than 36. X squared is greater than 36. Now, one thing I want to note, your leftovers must always say, if something, then something. Do we have that? If something, yep, that's their first part. So down here, if something, yep, that's it. That comes right down here. Then what occurs? X squared is greater than 30. You would never have a statement that says, then. If you end up having something that says, then something, that makes no sense. That would mean you've done something wrong or they've done something wrong. Now you got to read Part C carefully. If a triangle is equilateral, then all of its sides are congruent. If a triangle is equilateral, then all the angles in the interior of the triangle are congruent. Does it have repeated parts? Where are the repeated parts? If the triangle is equilateral. So let's mark them out. Let's mark them out. What is the leftover? I just talked about this. Once again, we mentioned this already. We said, can you have a statement that says, then something, then something? No, we cannot. So, can we use the law of syllogism? Can we say a then? No. So we cannot use the law of syllogism. Make that note out to the side. We cannot use or can't use The law of syllogism. Why? Because we can't have a then. Now try these two checkpoints. See if you can get these correct. One of them uses the law of detachment, and it says it right here. The other one uses the, it tries to get you to figure out which law of logic they're using. So law of detachment or syllogism. Try them on your own. On number 1, it says if 0 degrees is less than measure of angle A is less than 90 degrees, then A is acute. This just means if this angle is between 0 and 90, then it's acute. There's an if-then statement, followed by, is that another if-then? No, it's a little situation. Which one is it? Which law of logic is it whenever you have an if-then followed by a little situation? Detachment, and it tells you to use law of detachment. So that should have been an easy one. So what we need to see is, does this little situation fit in to this hypothesis? Is 38 between 0 and 90? Then what's going to follow? It's acute. So all we have to say is angle A is acute. These are actually really simple if you think about them. Does this little situation fit in the hypothesis? If it is yes, then this follows. What if I would have given you the little situation, angle A is 100? What would you say? Then that one would be angle A is not acute. It's all about the little situation. Does this little situation fit into the hypothesis? And then make your conclusion from there. Number 2 says, state the law of logic that's illustrated below. Read carefully. This is the only thing we should be focused on right now. The first thing I would do is I would see, do I have an if-then followed by a little situation? Let's look. There's an if-then. And what follows it? Another if-then. So can it be law of detachment if it doesn't have a little situation right after it? No. Then it must be law of syllogism. Another way to look at it would be to remember, in the definition of law of syllogism, it just gave 3 if-then statements. It gave 2 of them and what followed after that. Let's see if that occurs. If you do your homework, then you can watch TV. If you watch TV, then you can watch your favorite show. Did it have repeated parts? In the first 2 statements, was there a repeated part? Yes. It's about watching TV. There's the watching TV. There's the watching TV. What do you write? You write the leftovers. If you do your homework, then you watch your favorite show. Is that what they wrote? Did they write the correct one from these 2? Did they write the correct if-then that follows? Yes, that is an example of law of syllogism. This next example is a little bit more math, a little less writing. It says, what conclusion can you make about the sum of an odd integer and an odd integer? So what they do is they come up with examples of odd integers. We like coming up with examples. Seth, give me an example of 2 odd integers. All right, so I heard negative what? Negative 2 is not odd. So another one that could work would be negative 1 and negative 3. And once again, it said it wants the sum of these. So I need to add these 2 terms. Negative 1 plus negative 3 is negative 4. Somebody else, give me 2 other odds off the top of your head. Yes. 7 and 5. I like it. 7 and 5 are both odds. Their sum is what? 12. What are you starting to notice about these numbers? They're all even. They are all even. So it says, what conclusion can you make? You need to restate, just like you do in English, the sum of an odd integer and an odd integer is even. That's what you should have written down. Now try this next one. It says, use inductive reasoning to make a conjecture. What's inductive reasoning again? Patterns. Good job. Good response. So make a conjecture. Now I'll underline the key part. The sum of a negative integer and itself. Try that one real quick. The sum of a negative integer and itself. All right, so here are 3 examples. If you notice, negative 2 plus negative 2 is negative 4, and you can see the others. What do you notice about these sums, these results? They are even. They are negative evens. I would take that. Another thing is, how would you go from here to here without addition? Okay, they're double. So you could say a lot of things. The sum of negative integer and itself is going to be a negative. It's going to be even. And it's going to be 2 times itself. That would be a decent response right there. So you would restate this, and then you would say it's a negative, it's an even, and it's 2 times itself.